Okay, question 8. So we're given a derivative, so the gradient function dy dx, and there it is. And we're told the graph of this particular function has a stationary point at 329/4. All right, so we've got to find the rule of the function. All right, so the rule of the function. So to find the rule, and the rule in this case it's dy dx, so it's going to be y equals something. And to find what it is, we need to anti-differentiate root x plus 6 minus x on 2 minus 3 on 2 with respect to x. Now I'm thinking this might be, I'm going to put a line down there because I'm thinking I might not have enough space here. All right, so I'm going to rewrite that root as an index, and so as an index it's x plus 6 to the half minus x on 2 minus 3 on 2 dx. All right, so let's have a look. We're going to anti-differentiate. So anti-differentiate, increase the power by 1. So if the power is now a half, to increase it by 1, it will now then be 1.5, which is 3/2. Divide by the new power, and because we're dividing by a fraction, turn it upside down and multiply. All right, minus x squared over the new power, which is 2, but we've already got a 2, so it's 4, minus 3x on 2 plus some constant. All right, so now we've got some constant there, and we need to find out what that constant, because we're asked for the rule. So we need to know, we've got part of the rule here, we need to know what this constant here is. And we've got a point, we're told that there's a point there, 329/4. So we can substitute that in. And so when we substitute that in, the 329/4, we'll get that 29/4 is equal to 2. 3 plus 6 to the 3 on 2 over 3 minus 3 squared on 4 minus 3 times 3 on 2 plus some constant. Right, so let me neaten some of this stuff up. 29/4, 2, and that's going to be 9 to the 3/2, or over 3, minus 9/4, minus 9/2, plus c. All right, so let's go over to here. I'm glad I put that line there. 29/4 equals, all right, so 9 to the 3 on 2. There's a few different ways you can think about that. That's 9 to the half to the 3, which is 3 to the 3, which is 27, times by the 2 that's there, so 54 on 3. Nice numbers they've chosen for us here. And then we have a look at these. To add these fractions and subtract these fractions, we've got to use common denominators, and we got 4, 3, 4, and 2. Isn't that nice? The only thing that each of those go into is 12, of course, but what I'll do first is I'll move all of these things with the c over the other side. So I've got 29/4 minus 54/3 plus 9/4 plus 9 on 2, and that's all equal to C. And as I said, nice of them, because the common denominator here for each, that's not very good, let's move that because it's going to cause me problems, is 12. So 29, if you multiply that by 3, you get 87, and you're going to have to do this carefully. 54 by 4 is 216. Times by 3 is 27. And times by 6 is 54. And then when you add all those together, you got minus 48 on 12, which is, therefore, C is minus 4. All right, now we're asked to find the rule, so we've got to write it out. Even though we've got all the bits there, we need to actually write it out. We need to write y equals 2 bracket x plus 6 to the 3 on 2 on 3 minus x squared on 4 minus 3x on 2 minus 4. We must, if you're going to get all your 3 marks, we must write that last one, otherwise you're not going to get all your marks, because you were asked for the rule, you weren't asked for the bits of the rule, you were asked for the whole rule. All right, so there's that. Now it says determine the nature of the stationary point. All right, we've got the gradient here, and we know that when x equals 3, the gradient, because it's a stationary point, the gradient is 0 by definition. So what we need to do is look at either side of x equals 3. So say x equals 2 and x equals 4. I like to choose them reasonably close, not too far apart. So what we know here is when x equals 2, when x equals 3, I know that dy dx is 0 for this one because that's where our stationary point is, and when x equals 4. So let's have a look. So what is dy dx? All right, remember it's that root stuff here. All right, so x plus 6. So it's the square root of 2 plus 6. Plus minus, I think it's minus, isn't it? Yep, minus x on 2, so minus 2 on 2. Minus 3 on 2. All right, so that's square root 8. Minus 5 on 2. Now square root 8 is 2 root 2. And so now what I'm really interested in is this positive or is this negative? That's what I really want to know, because we really want to know what's happening either side of this. So is it going up and then down, or is it going this way? So I need to know what the gradient is. Now, rule of thumb, square root of 2 is approximately 1.4. All right. There's a mnemonic. I wish I knew the square root of 2, and if you look at the numbers of letters in each of those words, it's a reasonable approximation. So it's about 1.4. So what does that mean? That means that's about 2.8, and that's 2.5. So here we've got a positive gradient. We've got 0 gradient there. And then what have we got over here? So here we've got divide x, square root of 4 plus 6, minus 4 on 2, minus 3 on 2, square root 10, minus 7 over 2. Now, square root of 10, what's that? Well, square root of 9 is 3, and the square root of 16 is 4. Now, we got square root of 10, and 10's in comparison close to 9. I don't know why I put 4 there. It should be 3, shouldn't it? Square root of 9 is 3. Hope I didn't say 4. Hope I said 3. So the square root of 10 is going to be closer to 3 than it is to 4. Now, 7.7 over 2, that's 3.5. All right, so I'm thinking then that we've got a number close to 3 and we're taking away 3.5. So from that, I'm thinking then we've got a negative gradient. All right, so what have we got? We've got a positive gradient, a zero gradient, a negative gradient, and something that is like that is therefore a local maximum. All right, and I would be, it says determine the nature of the stationary point. I would be using the word local. Rather than just saying it's a maximum, I would use the word local because it's a maximum, and in that there may or may not be a maximum in the function itself. But there you go. So these here, if you chose other numbers, you might get easier calculations there and there, but it doesn't really matter what you use as long as you can determine whether in the end you get a positive number or you get a negative number like we did over here.